ஹலோ.
ஏம்மா?
ஹலோ, கேக்குதா மகிமா? ஹலோ.
ஓகேம்மா, ஐ கேன் ஹியர்.
ஹலோ, கேக்குதா?
ஐ கேன் ஹியர் யூமா.
ஹலோ.
Cool. Hello. Así te start from.
Hello. Good morning, sir.
Very good morning.
Shall we proceed with the session, sir? Okay. A very good morning to all. We are delighted to welcome to on an insightful webinar and exciting topic, how electrical power system really works in industries. Before moving to session, I would like to give an introduction about step in engineering. Step in engineering objective of services strategically crafted to provide holistic learning experience, seamlessly integrating practical application with indispensable software knowledge. Our major objective is to provide the foundational knowledge necessary to understand the main principle of engineering and their practical application in real-world scenarios. Our program focuses on meeting industry skilled engineers, aim to develop efficient professionals ready to succeed in their engineering mission. Our trainers for this session is Mr. Navani, the lead electrical and water drinking safety engineer. Meet the trainer, Mr. Navani, Mr. has over 20 plus years of experience, extensive industry experience in electrical engineering, oil and gas operation, assist integrity, and project execution, working across both onshore and offshore faculties. He has held and managed industry electrical power system up to 220 kV, including BTS, BGF, transformers, switchgears, HV by distribution system. VFDS, UPS, hazardous area installation. His expertise also covers plant commissioning, operation and maintenance, pipeline system, as well as integrity management and reliability improvement programs. He has held senior leadership roles at Crane Oil and Gas Agentia Limited, contributing to major projects involving pipeline construction, gas processing plants, offshore platforms, presentation systems, and plant turnarounds. Okay. A warm welcome to you, sir. Without further delay, moving to this. Can you take over the session, sir?
Good morning, friends. Let's wait for some more time so that other participants join.
Okay, sir.
Ashrat, you can see my screen, correct?
screen is visible.
Thank you.
Yes, sir, we can start.
Very good morning. Welcome to the this precursor training instrumentation and electrical. And today this session we will be discussing about how we are going to conduct this training on electrical part. And participants also can add certain value topics in case they specifically want to focus. We will take up that one, and this instrumentation part will be done in next week by my colleague. And today we are only talking about and only about electrical and industry focus on electrical systems. And very good morning again. Once again, my name is Navneeta Krishnan. I have almost 35 years of experience in construction, refinery, oil and gas, in various disciplines. Like I started my career in refinery as a trainee in maintenance and design. Then subsequently, I moved to petrochemical as a substation engineer. Then moved on to Lawson and Tubro as a construction engineer. Subsequently, joined in oil and gas. I spent almost 28 years in oil and gas. Currently, I'm working in high fluids engineering, Chennai. I'm taking care of engineering and design. Can you hear me? Yeah,
Yeah, now I can hear you. Okay.
yeah. Very sorry. I was on mute. It is habitual. Very sorry for that. And this training, unmute. This training we are focusing on electrical and instrumentation, and this part we are speaking now, discussing is electrical part and electrical modules. What we are going to cover up, and training participant, those who joined here interested, also can send us request for any specific information to be added, which will be valuable. We will take it up. That is a commitment. We work here. And this part is for electrical, and my colleague, Mr. Manikarajan, will take up this precursor program in LinkedIn next week.
Hello, sir, voice is not audible.
You tell me. Okay, we are covering four modules. Out of four modules, the first module we are covering about industrial opportunities and electrical system. And each module we have 3 hours, and we may extend up to 30 minutes, 3 hours, 30 minutes for the question and answer and other any specific topic to be covered on this. We are planning to conduct this program for 4 weeks in electrical system. And basically, this is a E&I model, and the instrumentation model will be for 5 weeks. And the fifth module of instrumentation is going to be carrier development part that will be handled by my colleague, Mr. Monica Rajan. So electrical point of view, only four models, but this training is a E&I package. Please understand, it's a E&I package, not electrical alone. And this package, we are designing to suit for young engineers and those who are awaiting to join in industries, or those who recently joined, or having those engineers who are having lack of confident in working in electrical system. So those engineers also can participate. It doesn't mean that only students have to participate. Okay, why E&I? Why not electrical? Why not instrumentation? Okay, we thought most of the countries abroad, E&I engineers are, if you go to Singapore, E&I is must. If you say electrical, no one look into it, very rare. So that is why, and also the latter part of your career, down the level 5 years, down the level of 5 years, probably you have to work in instrumentation, mechanical, civil, and electrical. So that is why we want to take it E&I basis. That is the reason we devised this model as the instrumentation and electrical model. So M1 in electrical, don't fear, M1 is not mathematics 1, okay? This is industrial opportunities and electrical system we will be covering in M1. And subsequently, we will see what are the subjects we are going to cover. M2, we will be talking about one EHV substation SLD, and what are the components and how it is going to be designed, how it is going to be selected, what are the critical application point of view, what are the critical parameters we will discuss. Then in M3, we will be doing a power system analysis orientation covering short circuit, load flow, excuse me. So load flow, harmonics also will show, and we also will talk about sometime in motor starting analysis, transient stability analysis. So all this model with the ETAP will be model demo we will be doing along with the theory. Thus the M4 is it's a reserve module. We will be talking about project management. Basically, we concentrate on projects from end to end, how the project is devised in oil and gas or any other industries, and what are the stages of projects, what are the critical parameters, critical values we have to monitor, schedule planning, schedule monitoring, cost monitoring, budgeting, all some of the critical topics, because you know that 3 hours it is not going to be sufficient to conduct this. These models are very voluminous and like a sea. So what people really need, industrial point of view, design point of view, those critical only we'll be talking. And if any other interest participants want before joining, before the program planned, if we want to learn something, please message us or send us the details. We will cover those one. And career part, as I discussed, career part will be taken care by my colleague. So no two individuals are equal in the world. Why I put this? So I may be different. I can say that no, I'm having 40 years experience. Someone in this team's live program can knock me off. So each and individuals are different, each and individual's capabilities are different, but minimum basic things we should learn. That is why we devise this. I'm only talking, so far any doubt? Okay, I will talk about what is the difference between academic and industry. What is the gap in between? So the focus of academic structure is focus on campus selection, lack of practical exposure and skills, inadequate infrastructure, and mark-based system. And mark-based system in the sense we will think only about mark, not no acquiring skills or no knowledge. Lack of motivation. Okay, then unable to classify information. So the world what we are living is huge volume of information. So what to read, what not to read is very difficult to classify. So flooded with information and classifying information very difficult. That is why this training helps. And motive, secure mark that earlier we discussed. So if you see the industry, what they are really looking. So it's a high demand. Okay, business is done in seconds, in minutes, hours, or days, not on years together. Okay, nowadays the business is, that is why I put the tick point, expecting yesterday, time driven. So the high demand of the business demands more from individuals. Then only the business can be successful. Uncertain business volume. Today I'll get 10 projects. Tomorrow I may not have projects. So everybody want the job to be executed qualitatively within very short span of time. Time driven, cost driven, and output driven, quality driven. All these are very, very important for your project. Okay, any industry, you take any industry, it will be like that only. So that is why, so our engineers nowadays, the companies are looking for at least something, those who come and grasp the things within a month. That is what their expectation. So that is why the gap exists between academic and industry. Capital driven, consumer driven, variation in job skills. Consumer also you want, what we are doing in Amazon, I want another 10 minutes in Amazon. That is the expectation consumers are having now. Variation in job skills. So this point actually, when you are coming out of college or when you learn something out of the college and coming out, you will be going and joining some other company that the requirement will be completely different. So this is also another factor. Expose a different set of people and tools. In company, college you have friends, you have in industries friends, but when you go to business organization, different set of people. You can see some of the experienced people join here also understand what is happening in the companies. So each and every individual you have to deal with that. That is what this program is planned to reduce the gap between industry and academics. Those who studied in industry, those who studied in college, so they want to, how they want to bridge the gap, this training will help. Can I proceed?
Your voice is sometimes getting broken.
Okay, can you hear me, sir? No? Hello?
Yeah, now okay.
Yeah, okay, thank you. So can I proceed for next slide? So the idea is those who are having lack of confidence, they want to learn more skills, this training we planned. So there are gaps existing between academic and industry. That is what this slide says.
They're not audible.
So this is the model M1. What we are talking is what are the industrial opportunities exist for engineers, for electrical engineers. We know that we have power and utilities, renewables, which is coming up very rapidly. Recently, I went to abroad, Middle East, I could see that world biggest solar power plant they are building, almost 6 gigawatt, and even I could witness physically and personally, it's almost 2 gigawatt plant. So the massive requirement of renewables and installation of renewable energy plants are coming up. So it is a challenge for all the grid engineers. Recently, also in Spain, there was a blackout. So this is one industry coming up. Then IT, AI, and data center. Data center, huge volume of power you need for the data center's cooling purpose. And electronics and semiconductors coming up. So then we have space opportunity, pharma, refinery and petrochemicals, heavy industries, particularly cement. Here I am not shown here. The heavy industry, basically cement, steel, other major industries, construction industries, infrastructure development, road, buildings. Huge opportunities are existing for electrical engineers. Everywhere you can look for jobs. Oil and gas, upstream and downstream, midstream. Upstream basically exploration, production and operation. Midstream is transportation and refining, and downstream is petrochemical. So these are the industrial opportunities exist. India is growing. India also a lot of opportunities coming up. And certain examples we have shown: power system engineers, design engineer, cathodic protection engineer, field service engineer, subject matter expert, maintenance engineer, inspection engineer, protection engineers, UPS service engineers, variable frequency drive subject matter expert, embedded system designers, substation engineers. Like, so it is only example. Almost in the someone going to join in the real training program, I'll show the list. It is endless. Okay, the next slide, M1. We'll be talking about what are the soft skills required for the industry. People might have very conversant with the nowadays soft skills. Social media is very active. So we'll be talking about business thinking. What is a startup for a startup engineer or a 1 or 2 years experience engineer? What is the business thinking he need? What is the requirement of business thinking? And what is the customer focus he has to do? What are the positivity and can-do attitude he has to develop? Okay, then engagement, how to influence people, that is very important. So we'll be talking about collaborative mindset, etc. Like this, time management. These are all some of the critical requirements, how the young engineer should be. We'll be very shortly speaking because 3.5 hours is very, very less time. So then we go back to key electrical equipments, generators, transformers, AC motors, circuit breakers, protective device, other substation components we'll be talking in this module. In case this module not having sufficient time to capture all this requirement, then we'll move back to module 2. There we'll discuss additional components. So what we are going to do, we'll give the overview and the practical point of view, how the brushless excitation is designed, and then we will discuss about capability curve on generator, maintenance and inspection part, and we will discuss about one data sheet of a generator. Okay, similar way transformer test. What are the tests they are going to do? We will discuss. We will talk about something insulation index like absorption ratio, polarization index. Okay, and we'll talk about oil test and DGA and minimum how to evolve the DGA result interpretation based on IEC. Then we'll go back to motor. We will see the 2D cycles and how the motor is started in ETAP program. That also we'll see. That we'll cover in module 3 actually. And we'll talk about something VFD and types of VFD and UPS system, how in industries used, how the backup is designed. So what is the purpose of VPS? What is the purpose of VFD? So those aspects we'll capture in this module. Then CB and protective device. This CB and protective device we will try to attend in module 3, module 2 or 3, because time may not be sufficient, but for sake of representation I captured here. So we will see all these components, not components, equipments, data sheet, how the data sheet looks, what are the things you have to look into it. For example, generator, why we are mentioning subtrans interactants, synchronous reactants, those aspects we will cover. Critical parameters only, application point of view. The application point of view in the sense design, operation and maintenance. This point of view, any critical points will cover, because you all already might have studied in colleges, all covered. Okay, that is why you will go very briefly, very critical points. Can I move? Okay, and M2 we will discuss about one EHV SLD, and key components of SLD we will discuss in detail, and each component we will see what are the parameters we have to look into for the design aspects, and also we will see any maintenance inspection requirement, we will cover it on it. Okay, we will be displaying on SLD, and in that we will discuss about circuit breakers, we will discuss about CT, for example CT, what is knee point voltage, what is the class of CT, what is the purpose, where this class is applied, where this class is applied. Say for example, class P, it is applied for no differential protection. Why class PS? Class PS is very specific of differential protection. Why we have to specify knee point voltage for differential protection. So those aspects we will cover in CT, and we will talk about CT, PT class and standard PT nomenclatures. And we will talk about isolator duties, what are the types of duties used, mechanical duty, electrical duty, we'll discuss in isolators. Then we'll talk about surge arresters, how to select surge arresters, and we will not deep dive into insulation coordination. We will talk about only surge arresters, how surge arrestor works, how the curve works, how the surge arrestor rating is decided based on BAL. Okay, BAL is basic insulation level. Then we'll talk about lightning, basics of lightning, how the lightning evolved, how the lightning basic theory. Then we will talk about risk assessment, why we have to do risk assessment, what basis we need lightning arrestor. Just we will one slide we will run about, so that participants have very good idea on the lightning system. Then we also talk about hazardous area classification. In this hazardous area classification, we will talk about zone concept and hazardous area equipment concept, like zone 0, 1, 2, how it is classified, what are the parameters the chemical engineers or process engineers look into while doing the hazardous area classification, and after classification, what are the electrical engineers role, and what are the certification body available who are all certifying, like similar to COMPAX certification. In case future participants want, they want a basic knowledge before going to COMPAX, we can also undertake those in detail. Not in this training program, it is separate, we can conduct if participants want. So this is basically a power system analysis. What we spoken in module 1 will be done with the ETOP support. So we'll be doing a load flow analysis, overview concepts and the reference standards we'll discuss. Then short circuit study will similarly we'll discuss about standards and concepts and the importance of short circuit ratings, and what about the importance of expire ratio, how it behaves during subtransient region. Then we'll also talk about relay coordination, how the relay coordination is done, and what are the basic grading methodology available, how it can be done in running plant, how it can be done in a new plant. And R-Flash will show one example, and we also talk about NFA 70 requirements. NFA 70 says R-Flash can be conducted in two ways. One is incident analysis method, and another one is no risk assessment method. Not no risk assessment, it's a risk assessment method. Okay. So we will talk about NFA 70 2024 requirement. It has two concepts. One is incident energy analysis method. Another one is PPE method or risk assessment method. So the PPE prescribed by NFA 70 for a risk assessment method is different, and incident energy analysis method is completely different. And we'll talk about motor starting in ETAP, and also we'll share Excel based starting voltage drop analysis calculation and general cable and load voltage drop calculation. We'll show some example and we'll share the Excel to the participant, and they can use those Excels for any how to select cables, what are the factors considered while selecting a cable. There's a lot of softwares available, free softwares are also available in the market, you can look into it. But this will give a basic idea, and this Excel we will be sharing to you during the training period. And we also touch upon transient study of substation. We'll do some concept transient stability study, and we'll show the participant how the instability occurring. We'll show the heat up demo. So these are the three models we covered. Okay, I'll go to the fourth module, project management and engineering concepts. And we'll be covering stages of projects in detail. Maybe half an hour or 40 minutes we'll be covering. And stages of engineering we'll be covering. Engineering also is a part of project management. So we'll talk about conceptual engineering, we'll talk about basic engineering, we will talk about feed. So the feed is front-end engineering design. So it is a bridge between basic and detail engineering. And some company will not do feed, they will go basic to again directly detail engineering. It depends upon the size of the project. If it's a refinery project, they will go in detail. So then we talk about EPC, engineering, procurement, construction, and build operate model. Build operate model is someone build the plant A to Z and he'll operate for 10 years. And this is our build operate model. And we'll talk about procurement and construction. So procurement is one of the priority stage of the project, because that's a long lead item, different vendors, hundreds of vendors, you have to face challenges. Quality at the same time, you have to follow the quality requirement. Then construction, the main problem in construction is safety. Nobody follows safety. So safety is very important. During this discussion, we'll talk about phaser, project HSE assessment, risk assessment stages like phaser 1, phaser 2, phaser 3, what are the things they do. I try to cover it very shortly. Then pre-commissioning and commissioning. Why this model I taken up is for project management for the young engineers, the knowledge is very less, lack of knowledge is there. And also we'll suggest how the engineers can learn things like Primavera. I don't have Primavera experience. I have worked in Microsoft scheduler, but Primavera, you can learn Primavera for the project if someone wanted to go into project management system. So that is a very comprehensive software. And we'll talk about sometime very shortly change management. What is change management in the project? What is change management in the any field like maintenance and operation? And if time permits, we'll touch upon, if Indian candidates are more in the training, we'll touch upon CA regulations, critical CA regulation. So for any doubt, they have gone very fast. Participants?
It was okay.
Okay, we have come to heat up demo. I'll show what are the things we are going to take up in the training, but it will be only 2 hours maximum. So we'll be covering 1.5 hours to 2 hours. We'll be covering. We cannot cover full how to configure SLD model SLD in heat up and how to run analysis. But we'll be running through and we'll show. I think our team will share some demo software and you can practice, I think. Arshad, correct?
Yes, sir.
So what I do, I will first share the heat up model, then I'll come to this slide. So we have developed some sample SLD here, typical SLD for this training purpose. So this SLD, we have 3 16 megawatt gensets, gas turbine gensets, and we have section A. Are you able to see my screen?
Yes, sir. Visible, sir.
Yeah, okay. So we have a bus coupler here, and we have section B, we have a grid, and we have another generator connected here. And these are connected loads. Connected here, it is 4 MVA transformer. Normally, at the 415 volt, we use 2.5 to 2.8 MVA. But it's a special case. Some location is very difficult to get no different voltage. So for cost point of view, sometimes no, even the 4 MVA transformer is huge. This design point of view, we have selected this 4 MVA transformer. Okay, we have some compressors running here of 3.8 megawatt, and we have some compressors of 1500 kilowatt. Okay, this is a huge rotating loads connected here, and we have LV bus here 415 or 440 volt. Here it is again 440 volt section B, and some of the downstream loads are connected here. Okay. Anyone knows that transformer rated is for input or output in the group? Anyone lift hand? The transformer is designed for input or output capacity. Okay, the transformer is designed for output rated capacity as per IEEE. The transformer is designed for output input capacity as per IEC. Okay, so because the loss in the static machine is very less, so even little bit you overload 5%, transformer is not going to have problem for shorter time. That is how. But you should not neck to neck design the transformers. We will talk about in this training model. We will talk about how to select the transformers. We will be running a load flow analysis. We will do a load flow calculation. How we are going to do, because I forgot to cover in the model. So we will be showing you how a typical load list is prepared. Okay, those aspects we will cover. It will be very beneficial to young people, those who are aspired to be a design engineer, or even will cover something about operation, because we don't want to focus only on design. So it will be comprehensive design and inspection and maintenance. And in summer we'll cover how the transformer is designed, selected, rating of the transformer, how it is going to be selected based on your load. Okay, and we'll share the free Excel for your exercise purpose. You can use it for your knowledge, or you can use it in case we are working in a small company. You can use it there. Okay, I will show some demo here, and generators are, so how already this is done info. See, for example, generator 1, and ratings are mentioned here. 16 megawatt, 11 kV. Its operating power factor is 80%. 20 MA based on 80% power factor, 97% efficiency. It's a 4-pole generator. So it's 11 kV generator here. So the connected load maximum 9.5 megawatt, Qmax we given here. Okay. So the operation point value also given mentioned here, 9.5 megawatt. Because generators are derated, gas turbines, what we do here, why it is, somebody can ask, 16 megawatt you said here, you are only operating at say 12 megawatt. So these gas turbine generators, basically what happen, it operates on the rating is depending on your operating atmospheric temperature, the inlet air of the turbine, because these turbine ratings are basically given as ISO rating. Everybody knows ISO rating, it is 15 degree standard, 15 degrees centigrade it is designed. So they will derate accordingly. So when the temperature goes up in the summer, so you will get only 10 megawatt sometime, and the temperature drops in winter, it goes to 16 megawatt. So that is why we given here the worst, we cannot worst case scenario we have taken as highest ambient based on the 9.8. You can see the capability curve, how the generator is going to behave in this. So we'll touch upon what subtransient reactant, what is its importance. We'll talk about zero sequence and negative sequence, and Our ratio also very important with the okay, the initial breaking current will be very huge because of DC components. In the one of the model we are planning to cover what are the types of grounding, and we will touch upon concepts. So how to protect, we'll cover one chapter and one particular slide on electrical safety. Earthing types like isolated grounding system, resistance grounding system. We'll talk about how to set earthing transformers. But the topic is very huge. You'll be rushing during the program. If someone close, it's like okay, somewhere you do homework, somewhere you do office work, and watch this training, listen this training. It is very difficult. But you should be very active and carefully you have to listen. So we'll be covering earthing NGR design, we'll be covering earthing system, we'll be talking about GPR. Our human heart behaves during see how the human some injured. So people will say luck. It is purely luck because the human. Okay, anyone know what is our 50 cycles time? 50 cycles plus 800 millisecond cycle. That is 0.8 second per cycle. 800 milliseconds. In this 800 millisecond, which location of the cycle this will talk about that one particular things in our training program. And stability and exciter governor. Okay. So the reliability model also. What is this given is no failure rate per year. In this we can do what is the failure rate, mean time to repair, mean time to failure. All these are typical value from IEEE book they captured. I think. So we will touch upon all the models. Today I will just show how the load flow is conducted. So I explained already we have 3 generators, one grid. Grid is isolated generally. And we have high important gas compressors running here. We have 3 and here we have 1500 kilowatt, we have standby 3800 kilowatt running compressor. You can typically show how we are conducting load flow study. Recently we have conducted gigawatt. You can see how the generators are sharing load here. This reactive power. Okay. You can see the bus voltage, it is 99.99 here, and this transformers not mention any capacitor here. In case very huge, so we can consider capacitors nowadays. STATCOM has come. Wind turbines, how in offshore they collect. Nowadays the pickup point is in the power system is they collect offshore wind farm power and collect it, and we call then it is connected to a offshore modular substation. 220 or 400 kV transformers of around 300 or 1 kg of weight per square meter is going to cost million. So and long underground subsea cables are running between offshore substation. Huge reactive power. So maybe you can say roughly 200 ME or 300 ME draws. So it will be a challenge. Upcoming technologies are more focusing on reactive power compensation. The problem with solar is it is weak grid. Grid fault or any other faults. So nowadays, no grid forming, and we'll talk about grid forming inverter, grid following inverters. In this see the voltage is all within the level. By chance, if I am getting over, the buses are getting overloaded because of the substation is local to the plant. That is why you could not find any change in no voltage or no reactive power. By chance you are running a long cable, probably and we list what is the change in voltage, what is the bus overloading, anything is there. So all these things we do in the load flow study. So P and Q is important here. Are getting normal. So all these things will capture breaker, any thermal overload is a for this. So any okay, I'll another few minutes is there. What time? 11:40. So another few minutes I'll run short circuit analysis here. Standard for this, and so you can see the generator is supplying 6.1 here. So this, if we see this bus, it is rated for say 108 kiloamps peak current. So peak bus is safe now. You can see here the fault current is only 6. You can see here 25 kiloamps. Okay, so the design peak current, what you have to do, you have to divide by root 2. So then only you'll get the RMS value. Short circuit study is how the breaker is going to withstand this short circuit, whether within the design for the plant. So you don't know what generator you are going to select, what buses you are going to select. So like this key single line diagram, you will analysis or some other software like PSCAR or PSSE, or use any software which is proficiency for you, and check the components are. Say my load current is say 1000 amps. How I select my breaker? I have to say or 25% maximum. So in case you future growth anything you are going to plan, your plant is going to be double. So all these things you keep in mind. It is rational thinking you need there to decide economic point of view as well as breaking capability. You have to specify. It will reveals the bus capability to break the current. Okay, anywhere it is breaking thermal. Cable also you have to be very careful. Sometimes no cable fails on short circuit. That also you have to look into. You can. Because of time constraint, I'll move to the another model. Okay, I will show some. Done here. Yeah, I also have not modeled any relay here because only a typical diagram. Will show how to coordinate relays from downstream to upstream. See here, this time, tripping time, arc flash incident energy is directly proportional to your tripping time. The tripping time increase, your arc flash incident energy also. Three model, okay. It will be very comprehensive, and I'll be rushing through. You all, those who are joining, should be very. We'll rush through. Okay, we want to generate some reports. You can see here report how to say, for example, generate a label here. Okay, I'll let it generate. I'll how we generate the labels for the user point of view. Our flush bound 70% the square, working distance 24-inch, shock hazard voltage 440, limited. So we'll go to now say some other models like motor acceleration. Say for example, nameplate details given, and we have selected the impedance model. This you have to get that data sheet. You have to model here. Okay, then you have to specify. You have to get the inertia of the load. Plus, you can do the motor starting state. So you can see the load curve. This is the load coupled. Say for example, compressor. Torque curve. Okay, here itself you can find very easily. This itself will show this curve is little above this curve. It will not start. Mostly, it will not lie down. Okay, so we will model all this. Cable length is very important. Cable size is very important. All these parameters. Motor starting analysis. Whether let us see whether the motor is starting or not. So I'm starting this motor. You can see here motor modeled. All these parameters we given here. So then we started. Now I'm going to start. Okay. We are starting at when I go to 2 seconds. See here, it is taking no 95.56% voltage drop is there. 25% is bigger motors will be much lesser because it is completely 444 amps. It is almost 7 times it is taking. So you can see here next you watching dropping cycle wise. It is dropping 432, 428. That means the motor is see here 392 is coming down. It is taking almost see here. See, it will start 10 seconds just humming and see how the motor starts. It will be huge. Plant, refinery or no, petrochemical, huge petrochemical plant, his heartbeat will be till the motor starts. Okay, I'll show the graph here. Generator. You can see the graph how the generator voltage behave here. The full load arms of the generator rises because of motor starting current in the level. Okay, but what happened? The AVR will compensate for you during this period. In the motor starting, whether motor is starting, your generator is capable of starting or not. This 96%. Stability. Also how we done because it's because of time I'm rushing through. What are the events done here? So what happened? I LV bus A. Okay, three-phase fault we configured. The simulation time is so generally depending on the grid capacity and grid size. This the whether my generator is stable or not, that we have to see. One, see here, there is a fault. In the LV bus, okay, at certain time, okay, it is going to trip. Suddenly load dropped because of short circuit and tripping. Let's see how my generator behaves. The generator angle, power angle, you see the oscillation. You can see it is not much. Okay, this is 21. It is going up to 21. It's actually but no, it should quickly oscillate and settle. Otherwise, what happen? Your generator will go to out of. You can see the megawatt. Okay, so in this, you can find out your system is stable or not. Generator is stable or not. See that during the fault, what is happening here? There's a jump in the training. Okay, with that, I conclude my this module, and I'll go back to my presentation here. Specific topic to whatever we discuss to be deleted or included, participants can send to our add or delete certain contents what we discussed here so that participants get benefited. So mostly we'll talk about practical application, how utilized and how the power system really behaves. I'll share my experience, not story. I'll share my experience. All these things, insights will share, failures will share, certain things like 620 MA one transformer failed during commissioning. Just think of commissioning, pre-commissioning, all insights we'll discuss during the if in case no, I am also learn from you all, share your experience and share your requirements, anything to be added in this. We try to cover up in 3.5 hours in each model. Ashwat, can you take up? With the presentation over, and next one. Okay. Inform me. Hello, I'm audible. Okay, thank you. Just please be online. We will share some quiz questions for the participant knowledge. So we'll be sharing some questionnaire. So those want to answer first can raise your hand. So that okay. Are you ready all? Participants, someone. Okay, we'll share the questionnaire now. Okay, can you see the question or no? Connected synchronous generator operating at rated load, a three-phase fault occurs very close to the generator terminals and is after fault clearance. Governor troop setting, generator inertia, excitation system. Right or wrong, no problem. You can. Okay, can I move to the next question? Nobody interested to answer?
Generator,
Right or wrong? We are all, I
I
even
guess
sometimes.
generator's mesh, yes.
Okay, your name? I'll pass on here during near generator faults compared to foreign faults. Higher fault current magnitude and DC offset, lower system voltage. Okay, most suitable answer you can quickly tell. Electrical engineer should know, that is why I devised like this. For to you as well as your colleagues, please kindly repost so that give feedback in LinkedIn and Stephanie. iFleets.com or my LinkedIn profile you can visit iFleets. Please comment in that section, we'll take it up. Okay, any suggestion or you can also read. Thing is not only electrical, we are covering instrument module completely. Our colleague will be discussing about P and I or electrical, because electrical people also can go to instrumentation. I have seen many electrical people are logical things. Question number 2, anybody? No, pass. Okay, question number 3, synchronous generator operating at utility power factor increase. Active power increases, reactive power changes, active power unchanged, rotor speed.
Reactive power changes and active power uh, will be unchanged, sir.
Yeah, okay. Name? Condition most strongly indicates voltage instability in a power system. Increase in rotor angle oscillation, reactive power demand exceed. Okay, it's a very simple question.
Reactive power demand and
Transmission line, why does the receiving end voltage sometimes exceed the sending end voltage at lighter load? Line resistance. Okay. And for a long transmission line, why does, okay, this we have seen, why do grid connected inverters not ceiling voltage fluctuation to regulate active and reactive power independently to increase short circuit current contribution? New technology. Okay, I'll move. So, an asynchronous generator operating at maximum torque. Anyone? Very simple question. Okay, it is not under excited. Okay. So next, I'll move. Operates at 50% rated load, which loss remains approximately constant compared to full load operation. Load loss. Okay, it's very simple question. You all might have studied in
Iron
college.
loss.
Okay.
Four iron loss.
Person.
Selvanathan.
Sharon.
Purely resistive, highly inductive, highly capacitive, or unity power factor. Okay, next for two transformer. Turns ratio, polarity, percentage impedance, core material.
Turns ratio, sir.
Normal condition is mainly caused by difference in, just think of, okay, R is less than XL minus XC, R is equal to XL, which is the correct term. Resonance when it occurs in electrical network. What is the term used to describe the total load connected to the secondary winding? Resistance, impedance, burden, capacity. On the relay,
Burden.
CT secondary, what it is called? Tell me again. Okay. Okay. Why is it strictly forbidden to leave the secondary winding of the, and answer it quickly. It will cause the primary circuit breaker to trip. It causes CT to act as a step down voltage transformer. It reduces the accuracy of the connected meters, which is the correct one.
B, sir.
Option
Produces
B.
option dangerously high voltage.
Option
Right,
B.
Okay. Raise your hand first.
Option
Who
B.
was that? Is that?
Option B, sir.
Option
Sharon.
B. I am Selvanathan.
Okay. Right. But the question 12 is for any electrical engineer, this is a very important question. The CT should be. What is the primary design difference between a metering class CT and a protection class CT? And metering CT saturated early to protect meters, but protection CT must remain linear during the high fault current. There is no difference. CT, you put the meter CT in the no protection CT and metering CT. Is it okay? Could you answer it? Yes, no problem. Answer, at least answer this. Number one, who is that?
C.
Rangan.
Ritika Bhaskar.
Rangan, not. Nice, Rangan.
Hello, sir. My option
Ah.
also C. C.
Myself also C.
C. Okay, very good. Okay, please raise your hand because 2, 3. What type of CT used for differential protection? Class 5P10, 3P15, class 0.5, class PS. Differential protection. Someone else? Next.
Class
2.
PS.
Who is the class PS? Can you raise your hand?
Which are like for protection things. I guess for class PS stands for
Class P is basically we call it as protection. 5P10 is basically used for overcurrent protection. Program. Class PS is for differential protection. Why? Because differential is very important. That we will talk in the training. Remove the hand. Ritika, please remove your hand. Okay, thank you. Yeah. Now remove your hand. Still it is. Then you can answer. Okay. Okay, Ritika, you can answer. Third is
Sir.
okay. Okay, please answer, Venkat.
Sir, option B.
D. D or B?
B. B. B.
B for bachelor. Okay. Okay.
Yes, sir.
What about Ritika? What about Sharona?
B, sir.
Okay, B. The right answer is B. Venkat has said correctly, and Shravana's Ritika, it is B. Lightning arrestor protects against direct strikes transmission line. Surge arresters are installed to protect the transmission line and the electrical switching electrical equipments. What is basic insulation level? It's a very simple question. Oh.
Basic insulation level, sir. C.
A.
Oh.
Sorry,
Okay.
basic
Talk about why industries, remove your hand. Why industries want to go away from SF6? Anyone have idea? Hey, it is not environment friendly. Who is going to raise the hand?
that is not environment friendly, sir. Lost.
Who is this? Selvanathan. Okay, very good. It is environment. It is not environment friendly is the correct answer. Okay, anybody knows any other option is available nowadays?
Yes, AVB makes some other mixed gas, sir. That instead of that.
Okay, very good. We have no few SF6 similar to SF6. We
GIS.
have GAS in the gas insulator substation. SF6 we are slowly eradicating. OEMs are eradicating SF6 and they are moving towards air, pure air insulated switch gears with some other additives and furon, not furon, some other material they're using, I forgot. I will let you know in the comments. Okay. And Hitachi and GE, they're using some specialized um, products and gas for their products. And now SF6 also they are doing with they're replacing with the gas. The existing switch is also retrofitting. Okay, in a standard industrial project life cycle, like oil and gas construction, does the feed phase typically occurs before the feasibility study, after the feasibility study, before detail engineering, after the construction is complete, during the commissioning and startup phase? Which one is the correct answer? Please raise your hand. A, B, C, D. A, B, C also you can say. Okay, Sharon,
Sir. Option B, after the feasibility study, sir.
but before detail engineering. Very good. What about Vengat? Who is that Vengat?
Yes, sir. B only, sir.
Okay, thank you. Thanks.
Yes, before detail engineering only the feed.
Okay, next question. Because of time constraint, I am moving very fast. Which of the following is the correct technical expansion of feed? Final engineering execution design, front-end engineering design, first era engineering development, foundation engineering and essential design. Which is the correct term? Vengat?
B, sir.
Okay. Okay. I think thank you. With the end of the program, we are coming up to the end. So any question anybody can ask openly, and please refer your friends. Those let them also get benefited. The important part is instrumentation, and electrical engineers also can they want to switch over to instrumentation. And nowadays there are many opportunities which is combined with instrumentation, like field service engineers of gas turbines, steam turbines, other systems like substation automation, all are interlinked with the instrumentation system. So that part is going to be very interesting. Please join on live when it is not live program. Jan 20, no, live program, instrumentation, similar. January 3rd, same 10:30. Time we don't know. Please look into our step in engineering page. So instrumentation model similar to this 1 hour program will be conducted by Mr. Manikarajan. He is also having highest experience. He is masters in DCS and also instrumentation, and also he is training excellent mentor. So please try to attend. Please refer your colleagues and look forward to attend along with all of you. Okay, any feedback?
Thank you very much, sir, for taking your time to conduct this excellent session. I hope it will be very useful for all the engineers attending. Attendees, if you have any question, please post them in comments. And before we conclude, we would like to announce a limited time early bird registration offer for our ENA training program. The actual fee is 50,000, and with the early bird offer, you can enroll for 12,000. You get 20% offer. The program starts from 24th January. Will be conducted on online Microsoft Teams, and this offer valid till 29th December 2025. Only 2 days remaining. Don't miss this opportunity. Grab your offer. For more details, visit the Step Engineering website and our LinkedIn page. Thank you all for your active participation. We will announce the winner soon from our official Step Engineering LinkedIn page. Thank you, sir. Thank you all.
Excuse me.
Yeah, you can see the this training program schedule. Still time is there. You can refer to your friends and let them get benefited. College students or those who are having 1 or 2 years experience, and even we cover for experience maintenance and operation people also get benefited out of this, because I'm not going to talk only design or basics. It will be very comprehensive. You might have seen today how we have focused in 1 hour. So similar way we will definitely conduct. It will be very useful. You can see the 24th is the industrial measurements and control system instrumentation. Then again 25th Jan engineering design essentials. 31st Jan, it is smart plant instrumentation, introduction and application. First, it is industrial opportunities and core electrical system, is my model. Then on Saturday again, electrical design, SLD interpretation. Then power system analysis and protection on 8th February. And 14th February, industrial readiness and project life cycle. Then 15th, resume career development, electrical instrumentation is by a instrumentation head. So these are the models we are covering in this part of training program, because these two are is integrated. Okay, thank you. Please comment. Please give your feedback. We all know, look for your feedback. Without feedback, nothing works in the world. Okay.
Today's webinar is over, no?
Yeah, we are going to conclude now. You can give
Okay.
your feedback, how we feel. You can openly, you can now also express, or you feel shy, you can post it in our page. We accept the criticism as well as positive when anything is a negative anything for improvement.
Thank you. Thank you. Thank you.
Okay, thank you all. With that, we
No,
conclude.
I
Thank you.
could say something about it, this seminar. And
Mm.
when I joined this seminar a little late. So
Mm.
myself, Selvanathan, I'm the entrepreneurs. I'm manufacturing for this RTCC panel and mastering for the transformers. And
Mhm.
we have this 8,000 followers in across global in RTS Evergreen. Actually, my name is Selvanathan Tamil Kannan.
Mm.
So this webinar is more useful, but I don't know this ETAB is earlier. So what are the things going on, how to design, that we doesn't know. Earlier we are using for MATLAB and the SolidWorks for this designing. But this differently is new about me, but it is I gained this very begin is the first things. So thank you for this opportunity, given this 1 hour webinar for free of cost. So I think this all participant has get some more benefit, and including me. So this is my kind request. It's okay that we will try to join, because we are in the manufacturing, but we couldn't able to do that many more time we are spending for that. So however, sir, thank you so much for this.
Okay, you are welcome. You can refer to your friends or your company, any other companies for any say prototype training also we can conduct. Okay, or this training also you
I
can
have
recommend.
one question, sir. We are receiving some foreign inquiries also for the exact field work, like the transformers, tanking, OLDC, the refurbishing and maintenance and other assembly, core coil assembly, other things. This kind of expertise available is there, that we can take as initiative for consultant service for abroad for the training, so that we can give a offer for you, that secondary, the third party um accessible things.
Okay, we'll
So
look at it, sir. Yeah. Hello. Okay, can we conclude? Okay. Thanks a lot for all of you for joining and taking your time, because in this world the time is very precious. Spending 1 hour is hope it is very useful for you. Thank you for giving opportunity to speak to all of you. Thank you very much. Thank you from Step in Engineering.
Thank you, sir. Thank you all.
Thank you.
Let's wind up the session.